All right, so in the Explorer, we really already sort of stamped what we're going to see here. However, I want to have this live in our notebook. And so the first thing I'm going to do is actually name the equation of these two lines. And so right now, if I'm looking at this, I can see we go down 2 and to the right 1. And so my change in y is going to be -2. My change in x is 1. And I see that we hit our y-intercept, or our y-axis, at what point? What point is on that blue line for our y-intercept? Raise your hand, please. What is that coordinate point? Amir. Coordinate point. 0, -2. And so we're going to have, okay, a y-intercept of 0, -2, which means that we have a b value of what? What is our b value then? -2. All right, I also have a slope, right? Change in y over change in x, which is -2 over 1. This is just a slope of -2. Okay, so I know that this first equation, I have y is equal to -2x minus 2. There's that blue line. All right, let's take a look at the red line. Okay, well, right here is its y-intercept. Raise your hand. What is that as a coordinate point? What is that y-intercept as a coordinate point? Terrell. 0, 3. From here, we're going to go down 2 and to the right 1. Sound familiar? No, it's the same slope we just had. And so, change in y is -2. Change in x is 1. And so, we know, right, again, if we have a y-intercept, my voice should be the only one, 0, 3, means, Tamarine, well, voices need to be off, that our b value is 3, and we have a slope, again, of -2. Okay, building this equation, y is equal to -2x plus 3. And so, again, different slopes and y-intercepts, however, similar from the Explorer that we just looked at. Algebraically, so you have two boxes. The left one's going to be algebraically. Algebraically, we expect to see the same what's? Amir. Slope. Same slopes. Same exact slopes. They're both -2 here. And so as a reminder, right, these are some m values. With this, however, we need to see different y-intercepts, which are our b values. Now, I want us to actually take a second and think about this second part. Why is it so important that we have different y-intercepts or b values with parallel lines? Why is it so important that we have different y-intercepts or b values with parallel lines? Well? Say it again louder. They don't intersect. And so that is 100% true, right? If they have the same y-intercept, then these two lines are clearly touching at some point. But I want us to think about this, even take it one step further. What is the same on parallel lines? Not your question, it's right here. What's the same? Slope. If they had the same slope and the same y-intercept, what would be true about those two lines? Emiliana? Say what you said, louder, because it's right. Louder. They would be exactly the same line, right? If you have the same slope and the same y-intercept, well, you're just retracing the same line. And so it's so important that they have different y-intercepts, because otherwise you actually only have one line. Now, on the right, we're going to talk about what this is graphically. Graphically, this is pretty easy to see. Again, we've really already sort of named this on the Explorer. We have two lines that never intersect. Two lines that never intersect. Are there any questions so far about parallel lines? Okay, then once you have this, go ahead, flip your notes, please, so I can see. There, there, there. One second. All right, so example 1. Which of the following equations shows a line parallel to line 2x minus 4y is equal to 20? Now, we haven't formally seen this together yet. I'll just flip and I'll get you the front. We haven't formally seen this together yet. However, does anybody remember what form that equation is? It begins with the letter S. Amir? That is standard form. Very nicely done. This is standard form. And so the sort of issue with this right now, do I know what the slope is? I don't. Because it's in standard form, I don't know what the slope is. And so I actually have to change this. Okay, so if I have 2x minus 4y is equal to 20, we actually did something like this when we talked about literal equations. If I'm going to put this in if I'm going to put this in slope-intercept form, what am I really trying to solve for or isolate? What am I trying to solve for or isolate here? Nadi? One more time louder. The x. Well, let's think about it. Does slope-intercept start with x equals? No. Okay, so good change. We're going to actually end up solving for y. And so because of that, we're going to move some things around. And so knowing that we need to solve for y, raise your hand. What needs to move first? What needs to move first? Raise your hand. What needs to move first? Prosper. X. And so in order to move that x term, right, we have 2x there. I have a positive 2x. What am I going to do on both sides? Minus 2x. Now, on the right, I am offsetting this. I am not putting this directly into the 20 because our negative 2x and 20 like terms. Let me say it again. No. Right? Negative 2x has a variable. 20 does not. So I cannot combine them. And so I'm going to have negative 4y is equal to negative 2x plus 20. Okay, well from here, I don't want negative 4y, I want just 1y, and so I'm going to end up dividing, but what am I going to divide both sides by? Somewhere, say it again louder. Negative 4. Alright, so I'm going to have y is equal, well hang on, what's a negative divided by a negative? Okay, so 2/4 x, and then what is 20 divided by negative 4? What is 20 divided by negative 4? Close, careful though. Positive divided by negative is a negative, so negative 5, good. Only thing I'm going to do, 2/4, well, I can reduce that. And so what should I reduce that to? 1/2. All right, well, this is the original line. The question is, which one is parallel? Okay, so when we talk about parallel, we named, I need the same slope. And so whatever the slope of the first is needs to equal the slope of the second. And I need different y-intercepts. So b1 does not equal b2, right? These are really the things I'm looking for. All right, which two options can I get rid of very quickly as possibilities? Ashnay. B and C. Why can I quickly get rid of B and C?
You can quickly get rid of B and C because they don't have the same slope as one half.
Absolutely. They don't have the slope of 1/2. They're automatically out. And so I'm left with A and with D. Should I select A or should I select D and why, Terrell? So yes, we want D. I want to change one of the words you're talking about. They do have the exact same slope, right? Which is what we need. However, A also has this intercept. Okay, good. D has a different intercept, which is what we want. This we do not want. Because realistically, what is A? Come here, louder. It's the same exact line. A is the same exact line. All right, we're going to shift down to example 2. I'm going to go through example 2 a little bit faster. I can see that we sort of had a feel for this already. All right, we have line L is equal to y is equal to 1/2 x minus 3, and line T is parallel to line L. Okay, so again, thinking about parallel, slope are the same. B values, bless you, are not. All right, I have a point, -1, 4. I need to determine the line in, slope-intercept form. Okay, so I know I have to get something into y is equal to mx plus b. I know that my slope is 1/2, and I have this point, -1, 4. Now, I don't have a y-intercept, right? How do I know that that's not a y-intercept? Ashley? X is not 0, which means that that is not a y-intercept, which means I'm not going to use slope-intercept form to start. My answer needs to be in slope-intercept form, but that's not how I'm going to start. And so instead, I'm going to use point slope. And so I'm going to label this x1 and this y1. Okay, well, I know if slope is 1/2, x1 is -1, and y1 is 4. Let me plug those in. Y minus 4 is equal to 1/2 times x minus -1. All right, everybody, a double negative is a... So y minus 4 is equal to 1/2 times x plus 1. All right, and we actually wrote down these steps last week. If I'm trying to go from point slope to slope intercept, what's the first thing I have to do? What's the first thing I have to do here mathematically? I gotta distribute, right? Specifically, we named distribute your slope. And so this 1/2 needs to be brought inside the parentheses. So I'm gonna have y minus, hang on a second. I know that this is 4, but if I look at my other side, I'm actually gonna have 1/2 x plus 1/2. Now, because of that, I know that when I move this value over, it needs to have a denominator of 2 in order for this to work. And so I'm actually gonna get ahead of this and name that 4 times 2 over 2 is really going to give me 8 over 2. Thank you. And so it's y minus 8 over 2 is equal to 1/2 x plus 1/2. And now I can add the 8/2 and wind up with y is equal to 1/2 x plus, well, help me out. What's 1 plus 8? 9. 9/2. Any questions on example 2? All right, we're rolling right on through. Example 3 is admittedly much faster. So line K is graphed below. Write an equation for line M, which is parallel to line K, and passes through the point 4, -5. Now, the reason this one is so much faster, do they give me a specific form I have to use? No. And so I have a point here, right? As Ashley said, if this were an intercept, x would be 0. It's not. So I'm going to have x1, y1. But I don't have a slope. Well, how can I find my slope? I know it needs to be parallel to the line that's graphed. And so the equation I make actually has to have the same slope as the line that's graphed. Okay, well, we know how to find slope on a graph, right? Slope triangles. And so let's draw this in. There are 2 points already annotated for you, so we're going to use those. And so my change in y, raise your hand, should be what number? 3? Is it just 3, Will? -3. Be really careful, right? We go down here. So this is a -3. And we go to the right, which means that our change in x is equal to what number? Come here. 4. All right, so I know slope is -3/4. I know I have the points x1 and y1. And so, again, substitute these in. Y minus a -5 is equal to -3/4 times x minus 4. Clean up the double negative. Y plus 5 is equal to -3/4 times x minus 4. Why do I not have to change how that looks? Why do I get to stop right there? Up here? Yeah, again, as we started this problem, right, we named, it's actually not asking us for a particular form, and so because it's not, I get to stop there. There's no extra work needed that I have to do. What questions do we have right now on parallel lines? All right, big takeaway from parallel. Same slope, different intercept. Same slope, different intercept. You've got 1 minute. Get these glued into your notebooks, please. Go.